This is the second part of lesson 10.2, volume of prisms and cylinders. Okay, continue where we left off. We've got a few volumes to find without a picture. And so on something like this, I would suggest if it's a little bit hard at all, I would draw a picture. So a cylinder, you're just going to draw, these bases and connect them. It doesn't have to be perfect, obviously. But it has a diameter of 16, and so just make sure you understand that that means a radius of 8 and a height of 8. So we're going to say pi r squared, so that's going to be 64 pi, and then you're going to multiply it by the height. And so when you put that in your calculator, you should get 1608.5 meters cubed. Okay, go ahead and try number 8, and then come back and just make sure that you got it right. What you should have done with the radius being 6, I'm going to say 6 squared, so that's the r squared times pi, and then the height is 6. And so that should come out to be 678.58 yards cubed. Okay, go ahead and try number 9. It's a prism, and it tells what the base is, what shape it is, so you might want to just sketch that out. Okay, here's what I did. I did a little sketch of my triangle. So I started with this triangle on the bottom here and made it a right triangle. And it was 3, 4, 5, so I already know what that looks like. The area of that is going to be my 1/2. The base will be 4, height will be 3. And so that's going to be 12. And then the height of the prism, I was told, is 2. And so that's how high I'm going to stack it. So I just do 1/2, or sorry, that's not 12. 6, half of 12 is 6. And so 6 times 2 is 12. And so that whole volume is equal to 12 inches cubed. Okay, do another rectangular prism, and then we'll go on to a new thing. So rectangular prism, sketch it out, and then come back to get the volume. Because this one's a rectangular prism, this is just basically a box, and so this is where you can do length times width times height. And so you just have to take the 3 dimensions and multiply them together. So like I said earlier, it's the easiest type of volume to do. So that's going to be 144 cubic kilometers. Okay, the next thing we're going to look at is we're going to look at right cylinder versus oblique cylinder, right rectangular prism versus an oblique rectangular prism. So when we're talking about the word oblique, that's a new one. And so what oblique means is basically the same shape, but it's just kind of slanted. And so it still has the same height. I mean, it maybe seems like it would be shorter, but if you think about it, it's not. And I'll show you an example in just a second. But how you would find the area, or the volume, sorry, of the right cylinder, you find the area of that base, and then you stack it h high. You're going to do exactly the same thing with the oblique cylinder. You're going to find the area of this base, and then how high will you stack it? I have here a stack of quarters, and so that would make the shape of a cylinder. And so if I look at the volume that it's going to take up, it's going to take up the volume of all of these quarters. So 1, 2, 3, 4, 5, 6, 7, 8 quarters. That's the volume. So that's how much space it's taking up. Now, if I was to take these quarters and kind of stagger them like this, then you would have to agree that it's taking up the same amount of volume. I didn't do that very well. It's taking the same amount of volume, but it's more like an oblique cylinder. And so it's kind of like a cylinder slanted on its side, but it's still taking up the same amount of volume. It still has the same height. It's the height of 8 quarters. And it still has the same base, which is the area of 1 quarter. And so whether a cylinder is oblique or right, it's going to have the same volume. In that video, our volume is going to be the same. You're going to have your pi r squared and then times the height for a cylinder. For our right rectangular prism, it'd be the same thing. It's just going to be slanted, I guess. And so that volume is going to be your length times width times height, and it's not going to matter that it's oblique. With a right triangular prism, you're going to find the area of this right triangle, stack it high. It doesn't matter that it's oblique, you're still going to stack it the same. It would end up being the same thing if it was not oblique. Okay, next we're going to talk about this principle right here. It's called Cavallarius Principle. And what it is, it's just the idea that if two solids, so like here's two solids right there, they have the same height and the same cross-sectional area at every level. So what I'm saying is that the cross-section here is this right triangle, same exact right triangle, same exact right triangle. And this solid has the exact same right triangle. It's just like scooted over. And so it has every level. They're going to have the same volume. And so that's what I showed you with the quarters. That's just illustrating Cavallarius Principle. So if an oblique prism and a right prism have the same base area and the same height, they're going to have the same volume whether they're right or oblique. So in the next pictures, we're going to find the volume of the solids that are shown. Round your answers to the nearest hundredth and use your pi button. So I would like you to pause the video, and I want you to try out these different volumes of these oblique shapes. And there's one that's not oblique, but I want you to work on that, and then I just want you to come back and just check all your answers with the video. Okay, for the first two, we have an oblique cylinder. So what I did in the red is I wrote the pi r squared. That's the area of my base, that's the circle, and then I multiplied it by the 15. And then in the green, I'm just illustrating that that's the area of the base, whatever shape it may be, times the height of the solid. And then so I'm going to do that math, and I come out to 1178.1. Okay, and then for volume of the oblique cylinder or prism, I'm doing the area of the base, which is the 35 times the 14, and then I'm going to stack it 24. So when I do that math, it comes out to be 11,760, and that's in inches cubed. I should have written that over here, centimeters cubed. For this next one, it is a right triangular prism. This one's actually not oblique, but I've got this right triangle and this right triangle, and they're congruent. And so that's the area of the base that I'm going to find. And you're also told it's a right triangle, and this leg is 4, and the hypotenuse is 5, so you know that that leg has to be 3. Pythagorean Theorem. So what I did was I did half of the base times the height, and that's the 3 times the 4, and then times the height is 10. I guess you could look at this, depending on how you see it, it could look like an oblique triangular prism. So I guess it just depends on how you're seeing it. So I can look at it one way and it looks like it's oblique, and another way it actually doesn't. So just kind of depends on what your perspective is on that. Area, or the volume, is going to be the same either way though. So 60 meters cubed. Okay, for this next one, the way that I'm viewing it anyway, it does not look oblique the way that I'm seeing it, but it might look oblique to you. But it's a trapezoidal prism, so we've got this base, it's a trapezoid. And so I see on the one end, I am told that one of the bases is 8 and then the other one is 6. So that's where my 8 plus 6 came from. The height of the trapezoid is 4, and so that's where the 4 came from. So this part right here is the area of my base, and then I'm going to multiply it by the height, 15. So when I do that, I get 420 centimeters cubed. And then for the last one on the note, it's the area of my base. It's the area of a circle. So I did the pi r squared, so 4 pi times 5. And so that gives me 20 pi if I wanted an exact answer, so 20 pi. So back before we used calculators a lot in math, we did a lot of answers like that because we didn't have a calculator to calculate with pi, so it was just easier that way. Since we're using calculators a lot now, we do a lot of approximating for something like this because it just seems to like conceptualize better. If I say 62.83 inches cubed, you can visualize like a cube that's an inch by an inch, like maybe like a dice. It's going to take 62.8 of them to fill up this cylinder, and so that's what that's saying. You should now be able to complete your assignment for 10.2.